We'd invite everybody to come in and have a seat. We're going to get going with the panel. There's a big break here in another hour where you're going to have snacks and things out in the back. And so we invite people out in the foyer to come on back in. We've got the panel starting right now. We invite the panelists to come forward and everybody have a seat so we can get going on the panel. Thank you.
Okay, I think we're ready to get started. If I could have the background slides put on. Okay. Wait 1 more minute to fill in. Welcome to this panel. Topic is human advanced. My name is Alon Levy. I'm the Vice President of Language Technologies at Unbabel and an adjunct professor at the Language Technologies Institute in Carnegie Mellon University. Many colleagues and friends know I've been associated with AMTA for over 15 years. Timely topic. We invited 4 people from places that are working specifically on this specific technology. I want to just quickly mention their names. They're going to introduce themselves at the beginning. First part, they'll have a chance, each of them, to introduce themselves briefly, like 4 or 5 minutes a person, and say their background and specifically what they themselves and their entity is working in this particular area. So just to introduce them by names and order here from left to right. We have, I'm going to get your last name wrong. We have Watson Srivasan, yes, from Amazon AI, AWS, representing the work that's being done at Amazon. We have Marco Trombetti from Translated, who you all know very well by now over the last hour. We have Joran Wupker from Lilt, representing the work that Lilt has been doing in this area. And we have Jose Souza, my colleague from Unbabel, who's going to talk about some of the things that we've been doing at Unbabel in this area of dynamically adapted MT. So before I hand it over to you guys to just give 4 or 5 minutes each about what your involvement in this, I just wanted to set a bit of context, what we're talking about here, since not necessarily everyone knows exactly this distinction or this exact term that we're using to describe dynamically adapted machine translation. So when we talk about adapted machine translation, the fundamental concept behind this is that in many or most enterprise settings, what we're looking for is machine translation that handles specific characteristics of language that are specific to an enterprise, a domain, a particular use case. And the way that's typically achieved is take a more general machine translation model. These days, of course, neural machine translation models, transformer-based, are very, very dominant. and then adapt them further for that particular use case or domain or enterprise content, using content that is specific from that particular more limited setting. And the most common way that's been done for quite a long time, even in statistical machine translation days, is what we call static adaptation, meaning that in advance, a model is then using specific data modified in order to be more specifically tuned to generate translations for that particular setting, again, domain, use case, or enterprise. And then the characteristic of that is that adaptation is done in advance, and it creates a new model that then is used at runtime. And of course, if you do this at a large scale, you end up with many different models that are each suitable for limited particular use case, and you have to manage that complexity when we're talking about commercial settings. In contrast with that, dynamically adapted machine translation fundamentally tries to accomplish the same idea, but where the adaptation fundamentally happens at translation time, meaning we don't have in advance all those hundreds of different models. We start from typically some starting point. It's going to be interesting to hear from the panelists exactly what that starting point is. And at translation time, using whatever information is available, again, for that particular use case, the adaptation happens and translation is generated, intended to be suitable for that particular user, that particular use case. So that technology has been around for a while. There was dynamic adaptation, early work, even statistical machine translation days. It has evolved significantly over the last few years, and now in the day and age of our current best performing NMT. And some of the things we want to talk about here with the panelists is like, how is it evolving? How is, with the advance of the general technology, what is changing in dynamically adapted machine translation? Okay, so with that said, I'm going to hand it over to our panelists. Each of you, please, only like 4 minutes or so a person. Introduce yourself, introduce where you are, and what you're doing on dynamic machine translation. So we'll start with you, Watson. Thanks.
Thank you very much, Alon. Hello, everyone. My name is Watson G. Srivatsan, and I'm with Amazon Web Services, Amazon Translate. I'm the product manager there, and I have been with that service for more than 3 years. And in the 3 years, Amazon Translate grew from like handful of languages supported to now 75 languages and variants. And in November of 2020, we launched Active Custom Translation, which is our way of dynamically adapting machine translation using customer data. If you look at all the presentation, and you'd see that language is hard problem, and it is hard because the context is not always known. If a machine translation a provider can know all the context under the sun, then we don't need any more customization. We will be able to customize based on the incoming data. But it is not possible, and new content and new ways and new context gets created all the time. As new context get created, we have to empower our customers to bring their data continuously, and when there is a need, not just wait, have the data, put it in a storage, and then when time comes, update the model. We want our customers to make the most of their data as soon as the data is available to be implemented and to influence the machine translated output. So when I was at Amazon, when we had a choice between static adaptation and dynamic adaptation, it was really hard because static adaptation is easy, it's well done, others know how to use it. Whereas dynamic adaptation is easy from the customer point of view, but the implementation is super hard. So we took on the hard part. As Amazon, we say we invented on behalf of our customers and launched the Active Custom Translation. My 4 minutes is over, and then pass on. Yeah, thank you very much.
Hello, everyone. Yes, Marco Trombetti, I'm founder and CEO of Translated. Yeah, told too many things, so I will just make a short summary of my experience with adaptation. So we started working on statistical adaptation when we launched the product, MateCat. the CAT tool, where we needed to start getting interaction with translators. And we quickly identified that the main problem translator had, they don't want to correct the same error again and again. And that is something happening in the same exact document. So there's no way of retraining every 6 months, over months, etc. Translator needed that information now. They translate a sentence from the one after they wanted. And so that's how the first version of adaptation, the first idea of adaptation started. And with Marcello, that is now at Facebook, and Philip, the first version came in that way. And then with Modern MT, we basically moved it to neural. And in about 2014, 2015, static neural models were starting beating and winning over our adaptive statistical system. And so very frustrated. And then luckily we came up with an idea to do adaptation on neural. And so we started then building on top of that. We started with sequence-to-sequence models, and then sequence-to-sequence with attention. And that was the baseline model, and on top of it, now there was a module to doing adaptation, so runtime machine learning. Alon described it correctly, something that you basically do the training at runtime, but because you do at runtime, you can adapt immediately to the changes, including the last change from the translators. From that, basically the transformer came out, transformer generic started winning over sequence to sequence with attention. And so we started now building up the model on top of transformer, and now we're waiting for the next technology to come to build on top.
Hello, everyone. I'm Jörn Wübke. I lead the research team at Lilt. I have been with the company since it was founded 7 years ago. At the time, it was basically just the 2 founders and me hacking on the technology. And since then, we have developed into a 150 people company, which is a language services and technology provider for enterprises and governments. We serve our customers by augmenting human linguists with AI, which is why we are focusing on a human-in-the-loop machine translation workflow, where the human linguist and the machine collaborate to produce a final translation. And the goal of this is not only to improve the efficiency of the translators, help them produce higher quality output, but also to give them the best possible experience, which in our case means no post-editing. Instead, we're focusing on a interactive, predictive typing workflow for the translators. And also, it means immediate adaptation to every single action the translator takes. So we have we implement 2 different types of adaptation. One is batch adaptation, which is triggered whenever a user uploads a translation memory. And secondly, the immediate online adaptation, which happens while the translators work and learn from every single sentence that is being completed. And we are, what is very important to us is that these happen in the background, that these are kind of transparent to the users. Both of these happen in the background while the translators work. And as such, that means that the model that is being used to provide the suggestions for the linguists improves continuously over time and learns from every single sentence that is being translated by anyone in a specific translation project.
Hi, my name is José Souza. I'm part of the research team in Ambabo. I joined the company 2 years ago, more or less. Ambabo scales translation also using AI, similarly to other companies. The story is that we have different types of adaptation. We have also static adaptation and dynamic adaptation. Now with the transformer models, we are able to do to fine-tune these models, like Marco said. It's a technology that came in the recent years, and we are able to fine-tune this for different customers and have models specialized for these customers for different content types, tone of voice, and specific needs that the customers need. We have periodically retrainings of these models, which is the so-called static adaptation, but we also have the dynamic adaptation that we do in our CAT tool, more specifically. And one thing that we are super excited about is the so-called data retrieval augmented models that I think we are going to speak about later. And we are starting to experiment with that. So to keep short and sweet, yeah, that's it.
Okay, so we have several topics that I discussed with you guys in advance that we thought we'd have a discussion about. So I wanted to start basically with just observations about, with really rapidly evolving technology field and the capabilities of neural machine translation. I mean, Marco, you showed it very eloquently in your presentation, but NMT, the basic general models, let's say, from which all this adaptation is done, is getting better and better. So the room left really for adaptation is clearly shrinking, but has not disappeared and is not going away. That has presumably an impact on just the strategies that all of you apply in deciding whether to build statically adapted models, or what are the starting point for doing dynamic. It's not a choice. It's not necessarily, as you've heard, you don't have to necessarily either do only purely statically adapted or only purely dynamically adapted. But I wanted just to get opinions from all of you guys about, given where NMT is now and the state of our general models, or where do you see basically what has changed, particularly over the last couple of years? How is your strategic thinking about like how to leverage statically adapted and dynamically adapted models maybe evolved, given this, where NMT is today and where it's going? Any thoughts from any of you? No particular order, whoever wants to go.
Okay. So first, you said models are improving the quality, so there is less room for adaptation. I always thought in a different way, because the way we build adaptation is on top of the best technology out there. So every time we have an improvement, the adaptation works on top. And given the current way neural networks are designed, and I'm not talking about the different architecture that we can use in order to get some adaptation in the raw model. I'm talking about the gradient descent, the batching, all these things. Neural networks are big averages. So their goal, if you have 10 sentences in one way and 10 sentences translated in another way, they're doing a big average. And yes, you can try to add some intelligence to discover context directly in the baseline network. But what we discovered, the most important thing we discovered in adaptation, that overfitting in adaptation brings incredible results. So the context is so much different and fragmented that basically an overfitting, last minute overfitting of any network always gives a new advantage. And maybe it will be a little less when we completely rechange the way we train neural networks, but this, I think, will be a long time. We want to go through latent variables injection, sparsely get a mix of experts first, and then maybe we attack the other problems. So I see there is for a long time, adaptation is still very, very important, and probably even after.
Okay. Anyone else want to comment on that?
Yeah, what I want to comment on is the starting point that you mentioned, right? So whether that should be a statically adapted model, and I feel from our perspective, really we don't want to have any kind of static adaptation. We don't want the user to have to specify what domain they're working on. It should all be transparent to them, right? It should be the model should notice what kind of and learn the domain within the first few sentences that are being translated. And I think that becomes even more obvious or easier with the improving baseline, with improving general domain models, because they already show very good performance on a wide range of domains, and so it becomes less important to start from the from a statically adapted model, but rather just from the general model, and then keep adapting over time also to the domain shift that happens over time within a translation project or within multiple translation projects for a single user. And another thing that I found is important as the technology evolves is that because of the tendency for the translation models, for the general domain translation models, to become bigger and bigger and more billions of parameters, in order to be able to keep adapting in real time, the technology needs to take a step back and look at kind of smaller parts of the network to be able to adapt it, right? To find the most important bits that need to be adapted so that it remains manageable to do all that in real time.
Yeah, Watson.
And one of the main things I want to bring about the advantages of dynamic adaptation over static is there are two factors that contribute to improvement in your machine translation output. One is the improvement that we do in the baseline model, and the improvement that you do by bringing in more data. If it's static, you get the best of the latest world only when you update the model, and you keep track of all those updates. Whereas with dynamic adaptation, whenever you update the data or when we update the model, you get it. The second one is out-of-domain data. You build a static model and send in an out-of-domain data for the static model. Trust me, you will get rubbish. And this is where dynamic adaptation would know that, hey, this is out-of-domain data. I'm not going to use my data from my parallel data. I'm going to get it from the generic model, and at least it'll be as good as the generic model. And the other thing is cost. I mean, if you build a static model, I don't think there is another service provider that helps you build static models for free. It's cheap, but it's not free. But by enabling dynamic adaptation, there is no model to begin with. The model is built at runtime, and it kind of dies after runtime. So it is cheaper to do a dynamic adaptation.
Yeah, Jose, you want to add anything?
Yeah, I was going to mention something similar, that dynamic adaptation helps, static adaptation helps with the domain shift and the evolving of the data over time, but response time, so that you cannot train statically. You could very frequently, but usually you wait some batch of data to accumulate. In dynamic adaptation, it helps a lot with reacting faster to this shift. And I agree, it's also cheaper because you need to train for less time and you spend less money on GPUs. Yeah.
So I wanted to basically follow up and address this question of persistency, or basically what the starting point model is, because you mentioned basically you do one adaptation in batch basically, which is kind of to the translation memories or the background of that specific customer or translator, and then there's the dynamic that happens basically while the translator is working. I think that's kind of the biggest distinction, or why there may be slightly different approaches even across all of you guys, is this question between the difference between a post-editing scenario and basically as a MT helping a translator as they're translating and going along, which those two scenarios kind of require somewhat different things. And dynamic adaptation kind of is composed of both of them. So maybe you could actually say a few words, particularly I want to start with you, Jorn, about that distinction, of incremental adaptation as a translator is going along versus basically adaptation and on a batch, or basically and the persistence of that model. The question is static adaptation. That there's this idea that there are persistent models and you keep many different of them. And you use them again and again, whereas dynamic, basically these models are just for that point in time, and you don't even keep them typically. So could you address this issue of persistency and of the difference between a post-editing scenario and an incremental working with a translator scenario?
Okay, so Yeah, when it comes to persistency, basically what we want when we have when you're a language service provider and you want to translate, want to augment the humans with the AI to translate content, you basically at every single point in time want to have the best possible engine to make the suggestions, right? And that basically means for that specific project, we only always maintain the latest model. So whenever some new content comes in, we use that to learn or to increase the quality of the model, to adapt the model further towards that new data, and we throw away all the old models that we had for that particular project. And that can happen, well, as you said, in two different ways. Either someone uploads translation memory, either in the beginning of a project or even later if new data comes up that you want to ingest into the model while translators have already been working. Yeah, the incremental online adaptation obviously happens while there's one or even multiple translators working at the same time on a single translation project. Every single sentence that is being verified by a human can be considered as additional adaptation data, as additional data that helps us improve the specific model, to improve the suggestions for all of the translators working on that specific project. Yeah, and technologically, the difference between the two is quite interesting. The batch adaptation, or updating towards larger amounts of data, is kind of works out of the box because it's the same. It works in the same way as static adaptation, which is kind of a solved problem more or less. Whereas the dynamic adaptation, adapting towards single sentences, can be a very hard problem because especially the large neural networks that we have these days, the transformer models, they are very data hungry. They need very large amounts of data to be trained in a stable way. And adapting to a single sentence pair at a time can be very difficult and is a hard optimization problem.
Anyone else want to address this?
Alon, if I can, I would like to give a different perspective and talking about the problem that we're trying to solve with adaptation. Okay, and we've mentioned some, but I think that if we go to the problem, then how we do things becomes more clear. So, and I talk about our self-translated. We have 50,000 customers that's got big enough TM to have a static system. Okay, and on average, they translate between 2 and 3 languages. That means 150,000 models to manage. And if you retrain those models once per year, 2 per year, spending maybe €1,000 to do easy calculation, that's $150 million in maintaining those. If you ask yourself why in human translation, the adoption of MT is very low, that is the simple reason. Even a single professional translator with 50 customers cannot spend 20, 30, 40,000 euro in training. That's how much it's making per year working from home. So first thing was having a single model. And those models, by the way, stay there, nobody used it for a year. So first problem was having a single model, okay, that will serve the 50,000 customer with a quality that is better than the single static models. Because that's, has not been said, adaptation brings you a quality which is higher than the training static models because it can learn, cross-learns from those. So first thing, make it work so that we can use it. Otherwise, it's not applicable. Okay. And then the second thing is that translators, every single document, you have a specific style and specific terminology within the document, within the 10,000 words. You want those errors to be learned. If someone is working on 10,000 words, that's 20 hours of work. After 2 hours, you need to learn those. It's stupid to think that translators should fix and fix again errors for 10 hours of work. So that was the other problem that we wanted to fix. Then is the context adaptation, because adaptation is not only about training in real time on the TM of the customer, it's also document level translation. So when you have a full document that you're translating, today machine translation is done sentence by sentence. But if you have the full document, you take a context vector that basically is the similarity of the content against all the data that you have, You pick the data that are more similar and you retrain. So adaptation also means document level translation. So translations that are not only sentence level, but then they became document level. And last and more important things for the end user customers, most of our customers were coming to us and say, hey, there is an error in the machine translation. Can you fix it? I don't know how to do it. You know, that's neural net. This is a big black box. So you fix something and you break something else. Adaptation allows you instantly to fix that error on your own page. You go there, you add a sentence into translation memory, and that thing is solved. And not only, that error is propagated, the solution of that error. So if someone else is using a similar term, and I have examples that I cannot mention in this conference, but no, things can get very bad, especially with profanities and misspell that become profanities. So these things happen, how do you fix it? So that was the problem that we were trying to solve with adaptation. And that's why it exists. And so that's another view.
Yeah. So one thing that wasn't mentioned is that dynamically adapting, it is, because the adaptation happens at runtime, it is more computationally expensive and it takes time. And so, the speed of translation is typically orders of magnitude slower of the machine translation with all of this baggage to compare to like the models that are delivered through pure machine translation. Now, you made the point very eloquently, Marco, that 98% of for your biggest customers delivered in raw machine translation, right? So we are in a world in which the extreme volumes of content are largely translated fully automatically and not with the aid of either post-editing or incremental translators. So
it's a very good point.
So and we want the best MT for those fully automatic machine translations. So this is one reason why this strategy is quite important, of basically how to set up basically machine translation models, where to actually do static adaptation and use that, presumably for raw MT scenarios, and then how to use this, those same models as a basis for post-editing and or for incremental translation. So this is what I'm trying to get you guys to give us a little bit of the strategy, basically. How do you balance basically, the choices in building these models?
We'll do short and then I'll pass to other. What you said is exactly true. The problem that we faced initially was, okay, adaptive machine translation cost 3 times more computationally, which means 3 times more CO2. But the good thing is that you're no longer doing the retrainings of engines that you will never use. So if in translated, that was $100 million of CO2 energy equivalent, and now we're spending order of magnitude less than that. So overall has been the greatest impact for us in saving energy, actually, because you don't do the training that then you don't use. So in some application, yes, if you have models that you use every single day, all of them, many thousands of models use all of them, I think you will spend 3 times more energy to do it. Better quality, better performance, 3 times more energy. But in real case scenario, you're actually saving 10, 100 times more in energy.
Okay. Anyone else?
Yeah. So just trying to address what you were saying about where to use static and where to use dynamic. Yeah, just to reinforce that the static adaptation, is usually used in scenarios in which you don't need this fast response to any change or correction made by the user, while the dynamic you do. And I just wanted to tease a bit on a bit of a different topic that I like very much, what Marco said about having one model. Because now, so what typically is done is you have like bilingual models that are built on a large amount of data, and then you fine-tune this large model, this big model, bilingual one, on your specific in-domain data for your customer or for a specific use case. This process of building this bilingual large model is very time consuming, it's very expensive, and it's very, it's costly. And now we have not a new kind of technology, but we have an expansion of the transformers that have been used for several different tasks, and it's called the large pre-trained multilingual models. And with these kind of models, we start to have the opportunity to have like the one model that is going to serve different use cases. And this is something pretty exciting that we started to experiment at Unbabel. And combined with the right way to use them with parameter efficient techniques for doing the fine tuning, you can actually have one base model and have only parts of this base model serving different use cases. And this is pretty exciting because this combined with a dynamic adaptation is more or less achieving this goal of not having to over and over have to build bilingual generic models that are based on some generic data, but you leverage what has already been done by the big tech, by the big companies. It's a very interesting perspective when combined with dynamic adaptation. Sorry if I got out a bit, but...
No, I think that's a perfect introduction, because I really wanted to bring up next, basically, the big innovation that's happened over the last couple of years is the introduction of large pre-trained multilingual language models, and they have now moved into machine translation. So we do have large pre-trained multilingual MT models, and that does change sort of the underlying landscape in a significant way. And I wanted each of you actually to say how that has basically affected your strategy and what you are doing. So the combination of these pre-trained models with now different strategies for adaptation, both static and dynamic on top of them, what does that look from your perspective and what you're doing? Jose, you basically already said, talked a little bit about what we're doing at Unbabel on that, but maybe the rest of you can actually address that question as well.
Yeah, I think it has basically two implications. The big pre-trained multilingual models. One is, as you already said, it means we don't have to spend the computational power and money to retrain what other people have already did, meaning the general domain models. And secondly, it means that the models that we're using become larger and larger, right? Because the pre-trained models are typically have a lot of parameters, and so for the downstream adaptation, you have to be on the technological side. You have to make sure that you find ways of adapting that are very space and time efficient, right? So that it's still applicable in the real-time scenario. And there's one exciting opportunity that I wanted to mention here. That is basically if you're using a multilingual, very large machine translation model, and you're adapting it with data for one language, you're basically adapting it implicitly to the same domain for all the other languages that it serves, right? So there are synergies between there that allows you, to adapt even faster, because like a typical enterprise scenario is you have English content, and you want to have the same content translated into, I don't know, 10, 20 different languages to localize your website, to localize your product descriptions. And with that technology, you can really, translation into one language has implications and improves the quality of the suggestions for all the other languages in that project, and I find that very exciting.
So if I look at the problem a little far from the marketing of the generative pre-trained transformers, there is one thing that I'm missing a lot from statistical machine translation. Statistical machine translation, we're managing monolingual data in an extremely efficient way. It was part of the formula. You could use monolingual data in a very efficient way. When we switch it to neural, especially at the beginning, monolingual data disappeared. Okay, and then through different techniques, we started doing back translations to inject it again. So you take monolingual data, you translate it to the model, and then you push this as new training data. It works for their languages. So We need a representation of the world in the model. And today, the architecture, the transformer that we're using, inherently does not have it. So we need to invent a new structure, network structure, that contains the representation of the real world. Now, is GPT-3 or similar pre-trained models a solution? I don't know. I like more the approach, for example, where Facebook is working on the sparsely gated mixture of expert and combining all languages, because this is an approach that I think with that approach and similar approaches, then we can think of reinventing also monolingual data in different ways and injecting it through maybe a new infrastructure, a new architecture. So these are the things that I'm really looking into. The non-conditional transformer, so something that just generates as a representation, is designed for something different. So I think in this industry, we need to design something specifically for our task. And I think if GPT-3 is very bad at translating compared to our models, I think same thing, we can invent something that will take monolingual data back and finally have it again.
So let me just recap the question that we are trying to answer. So the question is, how does large models change our strategy in domain-adapted machine translation? Is it correct?
The large pre-trained models, basically, and particularly the multilingual large pre-trained models.
Very good. Without getting into what Amazon Translate is doing into the large pre-trained models, what I can say is the large pre-trained models does reduce the footprint of any service to provide a synchronous translation service. So let's assume that a service supports 100 languages and everything pivots through a pivoting language. You would end up having 99 different models if they are bidirectional, or twice as many if they are unidirectional. But with large pre-trained models, you can just run a fewer number of cores to provide the same service. When that is there, the question is, that is the biggest value that the large pre-trained models, I think from my point of view, our point of view, would bring into the machine translation industry. It is going to make MT more sustainable. But when it comes to adapted models, it may or may not work, mainly because of the complexity, because at the end of the day, the customization is meant to provide a very specific kind of output to a customer, and a large pre-trained model would still, you need to host a particular core to provide the output to that particular customer. So the benefits from large pre-trained to domain adapted, we don't see a large opportunity, but certainly from the sustainability point of view, it is going to be a game changer.
Okay. Jose, do you want to add anything about like a combination of large pre-trained models and adaptation, dynamic adaptation?
Yeah, I think following up with what Mark was saying, and I completely agree that we need to kind of tailor the model to our needs in the translation industry. And it's very difficult sometimes in a transformer architecture to, how can I say that, encode priors or encode information that we already have, maybe call it meta information. I think one thing that is pretty interesting that is happening in the language generation research community is something called the data retrieval augmented models, which essentially boils down to have a data store in which one can input important data that needs to be generated. And this can be, imagine, product names, can be product specifications, it can be the right realization of a named entity or something like that. They have been used very successfully for language generation, and now people are starting to apply this to machine translation. There is the so-called KNN-MT approach, which is very interesting and kind of realizes this vision of being able to not only do the adaptation at dynamic point of time, but also combining this with these large pre-trained models, because in a vision of the future, you could imagine that you don't train these models anymore, you don't fine-tune them anymore. You just have these data stores in which you input the data that is important to you, and even error corrections if you want. And you start to just rely on this dynamic adaptation at decoding time without having to train them or fine-tune them. So I think this is pretty exciting, and it's something that is really unlocking new possibilities.
So it's basically some movement in the space now of actually having to train specifically, dynamically at runtime the parameters, versus basically leveraging all the rich sources of information that are in a data store or dynamically provided along with the input at runtime in order to generate the right choices, right?
Yeah, and of course you can also combine that with static adaptation. For example, you could have customized models for different use cases, and then also have this approach of data retrieval augmentation. So you kind of leverage the best of both worlds. It depends a lot on what is the application.
Okay, I want to leave just a few more minutes for questions from both the audience and also online. So just one final thing, kind of finishing this point that we were talking about. So there's basically now multiple ways to kind of accomplish the same impact of like generating a more correct, more appropriate translation given context, right? And basically that, as Marco pointed out, that's what we're trying to do with all of these things. So there's ways to integrate terminology now into general models. There's some amount of static adaptation, or what type of models you generate in the background to be ready, when translation time arrives, and then what's left to do dynamically at runtime. Looking forward, do any of you have any thoughts about, how the strategy for combining all of these different approaches to fundamentally accomplish the same thing? How's that changing, or how is that likely to look like in a couple of years or going forward, given where we are? Any thoughts?
So first, I have to say, honestly, we're pretty happy with the implementation that we do have today. So set on the baseline models, the state of the art, and then brings adaptation on top. And the layer that is created actually to user adaptive, context adaptive, so document level translation, domain adaptations. It does the three things in one simple API where you provide the sentence you want to translate and the full document or a portion of the document. And so from that, everything on can happen directly. So the implementation is very simple. So I think that the biggest opportunity we have in the short term is not a technical one, is that machine translation is not used in professional translation. Still, last 2 years ago, TAUS, 10% of the volume of our industry go through MT. I think domain adaptation as machine translation, adaptive machine translation, has the opportunity to bring machine translation to everyone, because we solve the cost problem, we solve the quality problem, and the boring stuff of correcting again a mistake. So I think that is the challenge that we have. How we get this to people, the benefit, this, and we solve the fears, and so that then they use it, they want to go back. So that is the main achievement, the biggest one, because if we do that, and then finally, all that data that we collect in industry, we have a feedback loop. Right. We have enough data to solve the language problem. And so that is, to me, the biggest goal that I have. Give adaptive machine translation to everyone so that we can collect the data, so that
adoption, basically adoption by the translation.
We can finally attack the problem.
Okay. All right, let's take some questions from the audience. We only have about 5-7 minutes left. So just go up to the mic. We'll start over there. KD?
I would like to follow up on what Marco just presented. The biggest winner of adaptive is the translator, right? When you're not using the translator in the loop, the benefit goes away. But the translator works in a cat tool. And correctly me if I'm wrong, but a lot of the adaptive is now locked to proprietary cat tools. If you look at the top 5 TMS and NER tools, it's not so easy to plug in adaptive, right? Amazon may be in memsource, but Amazon SAT is not, right? And if you look at XTM, not so easy to make modern MT work in XTM with a feedback loop. So is there some resistance from the TMS to adopting adaptive MT? Why isn't every CAD tool and every TMS already equipped with it, and particularly the big ones?
My personal experience that every CAD tool thinks, okay, I'm going to do my machine translation. And so they postpone the time from when they do the integration. Now, over the years, modern MT is in Trados, in MateCAD, obviously, in MemSource. Now, I think, Davide, what are we missing? MemoQ, okay? And MemoQ with the feedback loop. XTM, I think the integration is happening. So it's a slow process. And that's why I say that's my goal. It's slow.
And it's also a chicken and the egg problem. Only 10% of the translators are using MTPE. So TMS and CAD tools concentrate on the 90%. So you need to have a critical mass to have all the CAD tools use the adaptive translation.
Okay. We'll take a question from Steve, and then I'll take one online.
So for dynamically adaptive MT, you've got multiple, say you have a large project, multiple translators working on the same large project, same context. What have you done to determine, whose translations actually take precedence? Say that, different translators have different opinions about how things should be translated in this large project they're working on at the same time. It's all being dynamically adapted. What have you done with this? This is one thing that we've always discussed as dynamically adaptive MT became a thing, was the specific scenario where you have multiple translators dynamically, are translating, and it's dynamically adapting. And so has anybody addressed that issue? I'm just curious.
I think this is mostly for you, Jorn.
Well, thank you. It is definitely a thing we're thinking about a lot, but the thing is, it can't really be solved, right? Because as long as the translators don't agree, like who are we to make that decision for them, right? So basically, we'll more or less do a majority vote, or as the model learns from if the same phrase is translated by two different translators. In one way and by one translator in the other way, that kind of implicitly works in the model because more data takes precedence usually.
Can you build into your system the ability to give a particular translator, the head translator, some sort of preference? I mean, have you done anything like that?
We have not done anything like that yet, but we are thinking about it.
Okay. And that actually the question online that was fundamentally on a similar topic. Craig, you want to ask one last question?
Yeah, sure. Thank you very much. So dynamic adaptation, as I understand, has a kind of an assumption of a unidirectional shift of content, right? That you assume that as you're adapting, your new stuff is coming in the door. So on Babel, there's a lot of translation in the customer service industry where a lot of content shift is cyclical and seasonal. And in Christmas time, we see different content, and we can anticipate that with some adaptation. And I was curious to hear your thoughts on that kind of assumption of dynamic adaptation, whether you had any suggestions about how we can deal with that cyclical or seasonal content shift as well.
I can take a shot at that. So at Amazon Translate, the way the adaptation happens is if you have all the 4 seasons in your training parallel data, the way the dynamic adaptation works is it looks for matches, and because the input matches a particular season, it picks those season and provides you the seasonally appropriate machine translated output.
Okay. Anything else? Any final words? Where are we going to be in 2-3 years? Is it basically going to be some combination of seamless, static plus dynamic adaptation all happening magically in the background?
I can try. Well, if I could have a wish list, it would be to be able to do what I've mentioned before, having like fewer models maybe, because it's really difficult to maintain thousands of models for different use cases. And in a way that we don't need to burn a forest every time we need to train something. So leveraging something maybe of this data retrieval augmentation methods or something else that comes up or that we create, you know. So I think it's two goals. It's like reducing the cost and also increasing the opportunity to leverage and spread the usage of these models for different use cases. And of course, also, I think for me, one thing that is pretty important is always avoiding the translation of the same content over and over again with this error. That is something that also Marco mentioned.
Yeah. Okay. All right, I think we need to wrap it up here. Just for your information, there were quite a few more questions online that we weren't able to bring up. We'll try and keep the chat. If any of you guys are interested to respond to those, you're welcome to do that offline. Okay, I want to thank our panelists. Thank you very much. And we have a break. So how long is the break, Steve?
There are exhibits. Please visit the exhibitor tables out here. We've got some snacks and everything else. Thank you very much. Do you want to save the chat here?